This conference will now be recorded.
And we can see your screen.
Good afternoon. Good afternoon. You can see the slides. Can you see? Yep, you can see the slides. Okay, right. That'll set that. Okay, good evening, everybody. It's been about it's almost 10 years since I last did a presentation for the section, so it's good to be given the opportunity to present. I'm a committee member of the Nottingham Derby Section. Have been for some time, and would very much support Liam's request for some new faces, some support. It's not particularly arduous, and it'd be great to see new committee members. So please step forward if you can. So this evening, yes, I'm presenting on behalf of the whole project group. Now, there may well be other members of the project steering group on this call, but I know that I have Paul Gray of RSSB on hand to correct and perhaps answer any of the tricky questions that I can't answer, or even some of the might be some controversial ones, might be something something really to get our teeth into. So I don't need to introduce myself again, other than Liam's already done that. When I was delivering this project, I was employed by Ricardo Rail. I'm no longer employed by Ricardo Rail, but what will become clear when we give the presentation is that this is an industry-led piece of work, and the supply team was made up of a consortium. The project delivery was managed by RSSB on behalf of the industry, and the industry stakeholder group was extensive. So before we present anything here, we're not presenting something that I've written and take all the credit for, far from. This is an industry led piece of work. So my plan is to rattle through quite a lot of this because I want to get into some discussion. I want to get into some engagement with everybody on the call, and to see how people feel about what's being said in this research. As I've already said, it was extensive. Did we get it right? Did we get it wrong? Did we miss something? Inevitably we miss things. And anyway, the results of this research, before they become an instruction or embedded within a regulation or a standard, they're subject to further review by industry. So so there's still opportunity to change some of the things that are in here. So Paul, I know you're online because I can see you. Please just jump in if you like. What I've agreed with Liam is that I'm happy to take questions probably at the end of each quarter, because the way this is going to be presented is phase 1, phase 2, phase 3, phase 4. Phase 1 and 2 are technical, so probably more interesting to those on the call. Phase 3 and phase 4 about the economics. Should we implement some of this research? How would we go about it? Where's the economic justification? That's on the latter part. So I think what I'll do at the end of each quarter is I'll just stop and give everybody the opportunity to jump in. So Liam's just pinged a note. If you open up your chat window, if you put questions to Liam, and Liam will introduce them, and we'll do it slightly differently. We'll do it at the end of each phase. And if I say we're going to answer the question in the next phase, then we'll just say that and then move on. Okay, I don't think there's anything else on there. The photograph on the front there is what we mean by a differential permitted speed. Historically, they're known as non-standard letter differentials, those that are familiar with them. And what that means is, and it's not a compliant sign anyway, It's a good example of a non-compliant sign, but it means that everything can run at 20, and a diesel unit, presumably that should really mean a diesel multiple unit, can run at an enhanced speed of 30. Click through it. Okay, so project background. There are around the network, and I'll show you a map of the network in a couple of slides, lots of lettered speed differentials. There are several differentials on the network, and this is only one of several. So there are restrictions, which tend to be things like freight restrictions, 2/3 rule in the southern. The route availability system is in fact a restriction, but what we're focusing on here on these lettered speed differentials are permissions to operate faster than the standard. So when they were first introduced, they are associated with the type of rolling stock and the type of infrastructure that the particular line is operating. There has been, and it came to a head, and I for many years sat on Infrastructure Standards Committee, and have taken a break from Infrastructure Standards Committee when I left Ricardo, where people would come forward and make an application for a particular class of rolling stock to be a particular classification, as shown in the image on the right hand corner. And there were some questions about boundaries, shall we say, with regard to an ever-growing list of vehicle types listed against the classification. This project is in fact 3 projects. And that'll be on the next slide really, but it is several bits of research together, but primarily they're called T996, T1163, which itself is in 2 parts, part 2 and part 3. So this project is trying to aim for what do we mean by an HST, and have a look at the DMU, EMU and MU to see if we can come up with a classification, some parameters for that. And then also to wrap all the 3 parts together. Sorry, T996 was associated with sprinters. That was the first project we did, and then the whole project comes together with an economic case for should we continue with differential speeds? Are they beneficial? Is there any advantage of having them? The diagram on the right hand side is from the rulebook, the speed section. So at the time of starting T1163, and really this map goes back to T996 as well. T996 was the first project where we looked at defining sprinter. This is where we're at. If we look at vehicles listed, and now they're listed within the section appendix, as well as or instead of the rule book, because these classifications are area route specific. You can see that there in the Venn diagram is an interesting arrangement, and that's just the state we're at that time. And there's some pretty interesting things to be drawn out of just that Venn diagram on its own. Now, differential speeds and the introduction, application of differential speeds on a route is just one part of the whole route compatibility assessment that you would find in that group standard, or railway industry standard as it is now, 8270. All of those things on the screen need to be taken into consideration when bringing a new piece of rolling stock into operation, cascading a piece of rolling stock, or just changing something about the performance operations of the rolling stock. These need to be taken into consideration. And you'll see in the red box, differential speeds is in there. Would we like a particular type of rolling stock to operate at an enhanced speed over a particular route? The research that is included within this presentation was delivered by a collaboration of suppliers. It was led by Ricardo, and I led the delivery on behalf of Ricardo. And the support from the suppliers group was the University of Huddersfield, or the Institute of Railway Research, as some people also know it, and Sistra. And as you say by the little infographics, there's some collaboration, some academic brainpower, and some money and some economic modelling. All of this research is coordinated and led by RSSB. It's within RSSB's research portfolio. This project, that's where the numbers are allocated, the T996 and T1063. The organisations listed at the bottom are just some of the names that provided support in terms of engineers and operators from the stakeholder group. So there's a project steering group keeping an eye on the way in which the research pans out. So these are the 4 phases I just talked about briefly. Phase 1, which is to try and find where we're at the time, draw out some information from huge knowledge available to us. It's just accessing it. We included within that, some of you will have responded to a questionnaire that went out to PWI membership, because this organisation, there's as it said on that slide, thousands and thousands of years worth of experience within this organisation, and we certainly drew into what we could there. Phase 2, where we led by University of Huddersfield, was to have a look at the parameters that we think are significant, and then come up with some suggested groupings, maybe some boundaries as to what particular rolling stock types, classifications, how they potentially could be grouped. And that phase 1 and phase 2 is really the technical element in terms of vehicle track interaction, wheel rail interface, etc. Phases 3 and phases 4, led by Sistra, they looked at not only the potential classification of DMU, EMU, MU, but also and HST, but also the Sprinter that had previously been defined in T996. So that looked at all of the proposed classifications at that time. I suppose the final bullet point there is worth a comment. T996 was a definition of, provided a definition of a Sprinter. T1063, so that I always got that the wrong way around. 1063, 1163, sorry. T1163, part 2. Part 1 was should we do it. Part 2 was HST differential, and that definition was produced by RSSB internally with their own expertise and knowledge. So that was not part of phase 1 and phase 2 of this project. This was that was delivered by RSSB internally. So here's an interesting map, and you're all encouraged to. I wouldn't write down that. I don't. Maybe somebody can get that. Probably not do it now, but if we can get that URL into the chat somehow, you're all free to have a look. See, when we delivered T996, we had the Venn diagram which you showed earlier. Having a look at taking that a little bit further, having a look at where these non-standard letter differentials are on the network, and how they've been clustered, grouped, by region, area. It was fascinating. And the use of Google Maps and overlaying data provided by Network Rail with regard to the endpoint and start point and end point of a lettered differential was simply overlaid onto the coordinates simply overlaid into a Google database, and it's possible to go in and explore where some of these differentials are and see if some of them are on your area and see whether some of them could be challenged. Are they still required? Could they be withdrawn? Because, and we'll see this in the economic cases later, there can be cases for simply removing them if the infrastructure has changed since they were originally provided. Phase one, probably spoken a little bit about this already, but what we want to know is what was the background to the multiple units? What was the background to the HST differentials? Where do they come from? How did they come about? There are people on this presentation who will know the answers to some of that because they've been responsible for the implementation of them. The implementation of things like the sprinter differential are obviously associated with the introduction of the Class 150 because that was the first sprinter. For me as a child, it was very easy recognition because it had sprinter written down the side of it, and I remember catching sprinter trains when they were first introduced. But as you saw from the listings in the section appendix and in the rulebook, a 150 right the way through to a 171, 172 are quite different vehicles nowadays. With regard to the application of the MU, DMU, EMU and HST differentials, we had another look-see, and we did that in a similar way by putting questionnaires out, by doing a literature review, by interviewing, engaging with people. And that was fascinating to be able to talk to people with, dare I say it, 30, 40 years experience in looking after those particular assets. And they were great conversations and great engagement, and responses from members of PWI provided a lot of information about, do they recognise them, do they use them, were they implemented by them, have they been responsible for changing them, have they been responsible for updating, that kind of thing. So what we saw was that the rolling stock has changed more rapidly than maybe the signage on some of these routes. So maybe as I said before, some of them are no longer relevant, and maybe some of them are no longer applicable because rolling stock has changed and the rolling stock type in operation maybe have changed. And also the infrastructure may have been improved through track improvements. So what could have been traditional jointed track form, capable of 110 mil cant efficiency, has since been upgraded with concrete sleepers and jointed track, which would be capable of 150 mil cant efficiency operation. So some things, it depends what feature of the asset you're trying to protect. So we concluded at the end of this phase that we have some key engineering parameters, if you like, and they're listed there. So braking performance, cant efficiency, track forces, axle loads, route availability number. All of those things are of concern to members, members of this group, PWI members, because we've got an asset to look after. We've got the track form to look after. We've got track quality standards to maintain. What's going to cause track to deteriorate, and a number of these things here have a direct impact on our day-to-day life. And then the distinction between DMU and EMU is very difficult to find in this particular area. We don't have third rail, we don't have much overhead, not yet. So we're looking at different parts of the country and how they apply them. And the application of DMU EMU was indistinguishable, really, other than if you were protecting some weak overhead supply. So that was a great engagement with the industry, and we captured a lot of information. and we digested that, and then with the help or led by University of Huddersfield, we look at trying to determine some engineering criteria. So how could we go about classifying rolling stock and infrastructure in relation to MU, DMU, EMU? Various vehicle design parameters, limits on and use of current rolling stock classifications. Have a look at infrastructure. In many ways, the vehicle is easier to describe than the track, but we as track engineers, infrastructure maintainers, understand that some track is, dare I say it, more robust than other track. We have different track categories. We would all understand track category 1 through to 6. It may be that we have more or less a particular category, but we do understand that the track is more or less robust for various reasons. We understand things like equivalent million gross tons per annum values. We know what kind of efforts are required to maintain our particular assets. How's that going to change if we do something different with speed of the rolling stock travelling over it? So we, in this phase, looked at those things, and we developed a methodology. Whilst developing that methodology, we of course had to take into consideration that there are many existing rules and guidance, and they are listed. So I won't go into this particularly, but as you can imagine, these graphs have been produced by the university, by the team at Institute of Railway Research, and we are looking for sources of information about rolling stock. I don't know how people feel on this call. That's probably a point for discussion later. Where do we get vehicle data from? In British Rail, so British Rail Times, there's the rolling stock library, the R2 database, as some of you will know it, and that's where we get a lot of data. But in particular, newer vehicles, the R2 database is not very well populated, rightly or wrongly. It just isn't. So we had to derive some of the important vehicle parameters from the track access charging application process that's used for determining the charge for use of a particular rolling stock, rent of the line, if you want. What do we want to charge? Some vehicles do more track damage than others, basically. And then simply just asking rolling stock suppliers. So things that we're looking at there are things like axle load, so fundamental static axle load, dynamic vertical force, and dynamic lateral force. And the little dots are groupings of existing classifications of vehicles to see if we can see some natural groupings. And some vehicle types group particularly well, and some don't. And then we have to stare at this like a crystal ball and see if we can imagine something. So after we've done that soul searching with engagement with everybody we can, the conclusion of this section, phase 1 and phase 2, is that we have been able to come up with a table of important what we consider vehicle track interface parameters that would be associated with speed in particular, and then come up with some boundary conditions. We are all aware of the boundary conditions that would be in for any piece of rolling stock. You know, what's the maximum weight, what's the maximum axle load, what's the maximum dynamic force we can apply to the track. These are all defined within standards. You know, description of a deltic on the P2 force, description of a class 73 on the lateral track shifting force. There are existing boundaries already in place. In this particular project, we're looking at defining some boundaries within what we think are important parameters, and they're listed in this table here, and this table is extracted straight from the report. Now I think that takes me to a pause where we can take any questions about phase 1 and phase 2. So can I open up? Obviously, I'm not looking at the chat, Liam. Is there anybody come through with anything they want to jump in? And Paul, please jump in if you think there's something that I've got wrong or missed.
Paul's kindly shared a link to the map that's in there. the chat, and you have a question from Phil Holborn, who asks, did you consider using the National Gauging Database and or the D-Gauge Route Rolling Stock Database when working out what trains went where on the infrastructure?
We didn't. No, the rolling stock the answer is no, but I can't tell you where, because that information was pulled together by University of Huddersfield. I mean, I think the rolling stock type in operation is certainly listed in the section appendix, or the allowed type. But maybe somebody wants to jump in and clarify that. Anything else to pick out from there, then?
Yes, you do have one other question so far from Stuart Corrie.
Hello, Stuart.
Doesn't the data go back to Table D in sectional appendix? Sorry, Stuart, I'm not sure which.
What is Table D? Is Table D? I think it does. If it's the one I'm thinking of, I haven't got an example in front of me at the moment. So into the the vehicles listed in here. So that extract there on the right-hand side is from the rulebook, but the listings nowadays are in the section appendix. And we end up with some anomalies. I remember from 2996. I think a class 156 in Scotland is classified as an HST, but nowhere else in the country. But I think that is to do with the way in which the routes decided that they were going to manage signs. There are some added complications associated with the number of speeds you can have on a board. Our colleagues in human factors and driving standards, I guess, the people who are working with the trained drivers, we can't have 4 speeds on one sign, but there could be 4 speeds within the section appendix. So for example, the 2/3 rule doesn't need to be signed, but the driver needs to be fully aware that he needs to apply a 2/3 rule. And there are situations where we might find that we might want HST, DMU on the same board, but we can't. We choose to put one or the other, and that's an interesting discussion that could go on for a while. Have I got that right with the Appendix D?
I think Stuart was agreeing with you, but Stuart, feel free to unmute yourself, and if you'd like to speak.
If I had another screen and another arm, I could pull up an example section appendix, and there are some examples in the research report. There is opportunity for. I mean, I think we'll have more discussion about this than the section 3 and 4. So I don't mind coming back to this at all. When we talk about the economic case, I think something to bear in mind is the original introduction of lettered differentials such as Sprinter are associated with the class 150. Now, class 150s are still in operation as far as I'm aware, and derivatives of the Sprinter are certainly in operation, things like the 172, and I'm sure there are a couple more that have been brought on recently. They've got time to run, but the original introduction of lettered differentials, and I don't know if Andy Franklin is on the call, but he's certainly a key member of the delivery of this, would remind us of the state of the railway at the time that Sprinters were being brought on. We were replacing loco hauled coaching stock with a very track friendly, relatively, vehicle, because the maximum axle load was no longer the locomotive at the front of the train. The maximum axle load was, a nicely distributed axle amongst a diesel multiple unit, which turned out to be track friendly and therefore called a sprinter. And so the original state of the infrastructure back in the day is quite different from today, and they have to be reminded of that. And now what we do know, and this is a good point of discussion because it's something we will have to work with, is that there's a lot of new rolling stock come on in the last 10 years. Are we exploiting the benefits the best we can? And that's really the question for this presentation: is is there more we can squeeze out of the existing infrastructure asset? And that's the kind of question that people had 30 years ago. Is there something more that we could be doing when we go to a new form of rolling stock with the existing infrastructure without having to upgrade the infrastructure, either by choice or because we haven't got any money? Okay, any more questions before I move on to the economic modelling?
Yes, Josh, there's one from Colin Cotter asking you to elaborate on the 2/3 rule you mentioned.
Thank you, Colin. Right, 2/3 rule applies to Southeastern. We all know the history of the railway. Everybody does things slightly differently on their patch. The 2/3 rule is not a national rule. The 2/3 rule, as I understand it, used in the Southeastern. If Bob Hazel's on, please chip in, because he provided us with lots of engagement. It's a very simple freight passenger rule where the freight operates at 2/3 of the signed speed. Does that make sense? So it's a form of restriction rather than a form of permission, which the differentials we're talking about here are all about permissions rather than restrictions. Any more for now?
Nope, that's it.
Okay. So lots and lots of work. I mean, this is in terms of duration. This is well, discounting the HST and the sprinter classifications. This is 2 years worth of work with plenty of engagement. So I suppose what we should say there is, no, I'll leave the what next till later. Okay, great question. We love the research. We love doing the research. We enjoy looking at the history. We enjoy understanding our railway today. But the big question is, so what? Why? Why change anything? Why change anything? Just leave it as it is. And as time goes on, fewer and fewer of us will understand why it is the way it is. And we could just leave it. But actually, there are loads of challenges. So many challenges associated with change. All of these things here are business cases that could potentially form case studies that we could use to test, whether we should still have non-standard lettered differentials, or as the project went on, we called them differential permitted speeds to really encourage the idea that these are permissions to operate at a high speed. Some vehicles, for good reason, should be allowed to operate at a higher speed on particular infrastructure. And remember, the infrastructure is not just what we would necessarily have our front and center focused on. This is also about signaling, level crossings. There are gauging. There are many, many other things to take into consideration when do vehicle compatibility. Of course, this is really just focused on, should we put some more differential permitted signs up? Should we take down the 60 and replace it with a 60 and an enhanced speed of 80 for a particular class of vehicle, because it fits within the boundaries of one of these lettered differentials? So really obvious question. So new trains appear all the time. There are plenty of new manufacturers into the UK market. When the new trains come along, we move trains about. We don't suddenly scrap the train. Some trains, of course, get scrapped, but some trains get to live again, get second life and moved on, and they may be appropriate for them to operate at a higher speed where it currently isn't allowed because nobody's thought about it. Bimodes and trimodes, where do they fit in? During the project, we even thought about the BMU or the TMU, just to create another classification. Thankfully, we didn't actually, because one thing I didn't really emphasize is that we can't see much differentiation between DMU and EMU. So actually, the classification going forward is just an MU. Well, how do bimodes and trimodes fit in within the MU? Is it appropriate? Is there some benefits? Is there some opportunity for them to operate at a higher speed? I think at the moment, generally, we might think that bimodes and trimodes are the same vehicle, but just a bit heavier. How about service enhancements? More trains, more trains, more frequent service. Can we use differentials to reduce turnaround time? Can we fit a third path in when we only had two? You know, that kind of thing. And then of course, people should be thinking about how we do the infrastructure upgrades. So this phase 3 really looked at how can we monetize this? How can we make an economic case for this? And phase 3 was very much about developing the model, and the model in accordance with some rules, shall we say. We've got to play fair. We can't tweak the rules to suit us. So there are some standard Department for Transport web tag rules that people often use when trying to develop business cases for change on the railway, and we use those models. This work was delivered by Sistra, I forgot to say at the beginning. So our friends James Jackson and David Bishop both led the delivery of that, and they looked at those questions there that we could then use to challenge. So with the use of some case studies, what we did was made sure we got a good representation, a cross-representation of the kind of railways, the type of services that we operate, and see if we could challenge them. And we developed a benefit assessment model. The word's a little bit small to read there, I'm afraid, but this is all included within the research deliverables. And there's some two models. One is for adding differential permitted speed, and the other one is for removing it. And there's a process to take you through there. What I wanted to get to is just some of the output. So phase 4 was about can we test this with some case studies, and we ran 4 case studies. And I'm just giving you an example of one of those case studies, which is actually the Settle and Carlisle line. And the Settle and Carlisle line has recently had some significant upgrade. As we will know as PWI members, there have been papers about this in the journal. It didn't have non-standard letter differentials first time round 30 years ago. It doesn't have differential permitted speeds on that particular section of line. The track has been upgraded. The signalling has not been touched. In 1960, the line speeds were significantly higher than they are today. Why is that? Is there any benefit in revisiting that? You know, could we justify a line speed increase there, either for the whole line for all rolling stock, or would we want to limit it to certain types of rolling stock? And this is the output, and this is economic modelling output, and I'm not prepared to take many questions about this, and I'll simply refer them to David and James. But really, the guys presented and convinced and engaged with the project steering group that there can be some benefits of operating with a differential permitted speed at 75 miles. So if we increase from 60 to 75, then we see a return on our investment, and we see more investment return at even higher speed. But do we need to? Because I think it's not. I think it's signaled for 75, but it's not signaled for 90, for example. Other case studies. different types of operation, different types of service. So the three other examples, and these are all detailed in the report, all have their own particular challenges to think about. And as I've said already, this is not just about turning the speed up. We can't simply do that. We need to take into consideration many elements of the infrastructure and the limitations that we've got in place. A common one that those that actually are responsible for the day-to-day maintenance of track asset will be very familiar with is the use of user work crossings, sighting distances. They seem to pop up and cause no end of frustration after we've sorted out our third way track alignment, and then to find that there's actually a user crossing that means that whatever we do with camp transitions and all the exciting stuff that we like to talk about in track design, then we need to overcome those crossings or road crossings. So there's some examples there. I won't particularly go through them all, but Lancaster Skipton, North Cotswold Line, Oxford Hereford, which has had a whole load of new rolling stock on it, we know, and then the Marches Line in Wales. So different parts of the country, different merits. Should we add a DPS or should we simply remove a DPS? Each one taken in their own merit, and we have a process for modelling that now. I think we've already touched on that, but that really comes to 2 slides. This is the penultimate slide, but we can summarise that there are some significant bankable benefits. As an economist talking, there's significant opportunity for investment in infrastructure, in the rolling stock, in the operations of the railway as a system, by the application of some of these differentials. So differential permitted speeds, the vehicle classifications that we've got there, Sprinter, MU, which I've already said is the, we don't propose to continue with the EMU, DMU. That will be merged in, and we would be able to put in new bimode trains into that description as well. And the HST. In the HST, I could do another half an hour on the HST, but there's all kinds of things in there, and I think people who remember how an HST is considered to be, the modern version of the loco hauled. It gets to 125 because it's got a locomotive at each end, and it can brake quickly because it's got a locomotive at each end and a lot of coaches. So there's all kinds of interesting things within that. And the power cars are generally lighter than some of the locomotives at the time. But as I said, there's another 30 minutes there. So last slide, and then we can open up questions for phase 3 and phase 4, and then open up questions for anything. And I'd like to have a bit of a chat before people disappear off to get their dinner. We have a clear way of describing. I'll add on Sprinter because that was the previous. We have a clear, and I should say that criteria for the Sprinter is included within the published version of RIS 2711, which will be updated to include the classification that we've put forward, the criteria we've put forward for multiple unit and HST differentials. As I said, what's in this presentation is not necessarily what will go into the RIS. This is information provided to the industry and to be guided through the drafting process with support of Rolling Stock Committee, will be the lead, but with support from Infrastructure Committee and Operations, etc. Managed by RSSB, who obviously custodians and manage the RIS and the RGS and such. So we have got a business case, we've got a methodology, we've got 4 good examples. They don't all jump up and say, let's go and spend some money here, or some do, some don't. What you should do, what you shouldn't do, we'll give you some guidance. But we think there is an opportunity here to revisit some parts of the network to see whether we as a system, and maybe this fits brilliantly with the new organisation, and we can expect in the next 5 years to say, from a system point of view, let's get together and work out how, why, when we should implement some speed increases. Yes, there's some consequences to maintenance of the infrastructure asset, but then there's a service benefit to the travelling community. And I think I've already touched on all of those. Now, the last point, I think Paul would probably shout up if I don't. A lot of research delivered can sit still. It needs to come off the shelf and it needs to be used. RSSB is proactively supporting with engineering and maybe funding, because there are organisations like passenger transport executives, Transport for the North, and then Northerners at TOC, is an example where they would like to take this further, and the PTEs may well have some financial investment to offer, but we need to approach it from a system point of view, and we all need to get around the table together. That is the final slide. So I'll probably leave it there. It's a good place to start some questions. If anybody's got any specific questions about the economic model and the case studies, they would be great to start off with. But I would really welcome then a challenge about, so what? Why should we provide a better service?
See, there are a few questions in the chat.
Okay.
Starting with Rufus, who asks, does the rail infrastructure permit higher speeds on current lines, or is this limited to current speed limits due to safety or any other reason?
So line speed is controlled. We have within PWI design rules that we need to adhere to, and there are safety limits on those rules. So yes, there are safety limits on track design. There are also ride comfort limits. So things like cant efficiency are determined by ride comfort, and they are an interesting discussion as well, because some of those are fairly, should we say, well established or due a rethink maybe. The safety limits are things like the track loading limits. So you've all heard the presentations by Brian Whitney, and he gives his annual update about rail brakes, usually by vertical damage or but just track loading generally. So there's a direct link between speed and track loading, using the dynamic factors that have already presented. Not quite sure that answers the question, but that's my best go.
Okay, thanks, Joss. Next question was from Philip Holborn. Is there any kind of guidance documents or process available for designers to follow to identify where a differential speed may be of benefit and how to go about proposing the introduction of one?
That's a really good question. It's a really good question, and I say that because there is. So Network Rail has done brilliantly developing design tools in terms of track alignment tools fundamentally, but then also tools associated with whole life modeling. So deterioration rates, degradation rates, how the track quality is likely to deteriorate over not just time, but also tonnage and speed. And also, obviously, in the last 15, 20 years, we've been very much focused on things like rolling contact fatigue and the deterioration of the track, rather than just the track form as a lump shifting. Now, I don't think, and I think it's a really good question, I don't think there is an add-on to the existing tools. So Third Way, and the other one I'm forgetting at the moment. There's another tool that has been developed recently. Somebody can probably jump in and tell me. But those modelling tools, I don't know. I don't use them. I don't think there is a button that says "What if," but I can't see why you can't simply repeat the "What if" you know, have a track design for 60 for all vehicles, and then a track design for 80 with a more track friendly vehicle, should we say.
I wonder, Joss, if I could just add to that. We are
Hello, Paul.
Yes, sorry, yes, Paul Gray here. We are working on a couple of rail industry standards to try and take out the core bits of the T1163 work and try and put that in a standardized way, so that project teams have got the sort of confidence to use that approach, given that the standards would have gone through due industry governance and consultation processes. So there is some sort of buy-in, if you like, that from the parties, that it's a fair process and is appropriate to the decision making that's needed. So we are doing that. I think it's fair to say, as Joss has alluded, there will be particular specialist tools for both looking at signalling design and sort of braking type questions, as well as like the track design issues and other things like probably gauging as well, because if you change the speed, the dynamic profile of that vehicle could be significantly adjusted as well. So there's various other specialist packages for those particular compatibility areas. But the idea of these rail industry standards will have a try and tell it as the whole story, but then point to particular specialist areas where there is further compatibility assessment needed. But I think what's crying out for really is different project teams probably wouldn't even know necessarily where to start if they hadn't come across this issue before, and so this is like to explain the overall process and find a way through the various considerations.
So, a separate one thing I was just going to add to it is that the RIS itself has a guidance note, as do all RSSB standards like this. It'll have supporting documentation. So, you know, if you're proficient at reading the standard, then that's great. But if you're reading it for the first time, always go to the guidance note and also go to the deviations that might be in place. There's lots of background in those documents. They're often direct you to the original research that justifies the rationale behind the requirement. What I haven't talked about is that as we went through this project, and as I said, it took a couple of years, there are some live projects where differential permitted speeds are being implemented, and good examples are with the introduction of Avanti. We're challenging some of the rules associated, or the way in which one differential permitted speed they didn't talk about is the tilt, or EPS it's called. We didn't need to look at that because that's well defined, but EPS is a form of differential permitted speed. There are a couple of others that are on that Venn diagram. That Venn diagram. I know Avanti are looking at, you know, could they take advantage of EPS and MU in its current description, and I also know that Eastern, I'm not sure if I've got that exactly right, but anyway, the new rolling stock, the new flirt rolling stock being introduced into Norfolk, they were applying differential. So people are using them still, but I think you have to, shall we say, have experience of applying non-standard letter differentials 30 years ago to be comfortable and confident that you're using them the way they should be used. There is obviously opportunity to use them maybe how they shouldn't be used, to make preference to one rolling stock rather than another, but you know, we're trying to avoid that. Any more questions, Liam? I can see the clock says an hour, so I think people are probably almost had enough.
Sorry, I was on mute. Got
Okay.
3 more questions, Joss.
Go.
So Sankradev Chowdhury asks, was the existing timetabling taken into account as an input, or was the intended timetabling an output? I think this refers back to the case studies you presented.
Yeah, absolutely. So the reason we have Sistra on board to look at these to look at these case studies is because they are proficient users of the DFT web tag evaluation processes, and they are experts in timetabling and timetable modeling. Now the tools behind that, I'm no expert in those, but they have access to the existing timetables, and they were benchmarking against the existing timetables, and the benchmarking also is against, once you have that data, then you can benchmark your existing revenue with some future revenue. And I think it's in the slide here, the potential sources of making a change, whether you should make a change. So some of the answers were to not implement a DPS. There's just no benefit. Remember, the ideal, and we haven't touched upon this, is when we move to the new European signalling system. Within the new European signalling system, there is no existing option for differential permitted speeds, but we believe that system is far enough away in terms of time that there's plenty of opportunity to use these differential speeds and in the existing timetable. And so yes, we use the existing timetable, and then we model the delta, if you like.
Okay, thanks, Joss. Penultimate question from Stuart Corrie. Has any analysis of the future use of in-cab signalling been done to see how much benefit could be unlocked by the increased use or complexity of differential speeds?
Yes, I think I've probably just answered that in the previous commentary, so I can make this one short. The implementation of the in-cab signalling, I think, will restrict the use of differential permitted speeds. In fact, it could be detrimental, because we may need to operate without any of the speed enhancements. I mean, may need to take the speed enhancements away. Or the flip side, when somebody tells you that, you might need to try and work out which bits of infrastructure need amending to avoid having a differential speed, and simply upgrade the line speed for everything. Okay.
And the last question that's in the chat anyway is for Manny Jacannathan, who said, "Thank you, good presentation. He'd like to know whether any track improvement activity, for example tamping, was needed to be carried out to achieve the increased differential speed."
Yeah, there's another discussion about clamping and any other track maintenance activity, which of course the aim of any maintenance activity is to ensure that the track maintenance targets for that particular category of line speed are achieved, are maintained. So I don't think there's a direct link with use of tampers, with the use of stone blowers, etc. One thing we did talk about as one of the parameters for track, and I've touched on it earlier, is robustness of track. If we increase speed, what's going to happen? If we actually go from a category 5 to a category 4 track, shall we say, the maintainer will will benefit from a higher charge, if you like, so more money for maintenance, and that might be good news, because then you can do more maintenance, or maybe you just have to do more maintenance because you have to keep it at a higher. You've got to keep the track quality and where it should be, and of course maintain safety limits as well.
I think that's it for the questions in the chat function, Joss, but we could open it up if anyone has any other questions. Please unmute yourself and ask your question.
What I should say is, just whilst people are thinking, what I should say is that RSSB research deliverables are available. They can be. I'm not quite sure what the permissions are at the moment. Perhaps Paul could confirm this. But the outputs of research, they're funded by the industry, so they should be available to industry members on request.
Absolutely, Joss. Yeah, well, we want to promote the findings as well. Sometimes we have to be a bit careful about the data that we've used to recognise IPR for particular vehicles, say. But the report is available, and to RSSB members, and anyone drops me a line if they can't get hold of it, happy to help.
You've got one more question cropped up, Joss, from Graham. M. He said, you mentioned HSTs can have differential speeds due to their better braking performance and lighter axle weights. But how would, for example, TransPennine Express Mark 5s compare? Because being essentially a loco hold, would they still be eligible to be classed as a HST?
Yes, I think have I got the HST definition? So that's interesting, because in between doing T996, the definition of a sprinter, and T1163, Network Rail, Mark Burstow, if anybody knows Mark and his team, had a look at trying to apply differentials for TransPennine, but I think it's actually further out towards the coast. Now, I might get this right. Is it Scarborough to Leeds? I think it was Scarborough to Leeds, and they had a look at all the reasons why he can't do this. And this is where he came into things such as structures, areas where the track is shifts a bit, and user work crossings and things like that. And when he ran that model, he wasn't expecting that new service to be a loco hauled with the Mark 5s. Is it a Class 68? I can't remember. It's definitely loco hauled. Now the loco, I believe, fits within that bullet point in the middle of the screen. I don't know if you can see my cursor here. An HST, can you see my cursor? Nope. No. Okay, can you see my cursor now?
Yes.
Yeah.
Right, down here. So here we've got a couple of bullet points. So RA has been used to describe HST, and we do allow RA5, but it's caveated that we don't really want them to be. We wouldn't want an RA5 with uniformly distributed load. So we wouldn't want a DMU RA5, but for the historical reasons, because an HST is an HST, how could it not be? The power cars, the Class 43s, I think, are RA5. So in that case, they can. And I think the TransPennine, that new Mark 5, the Mark 5s are fine themselves. It's the loco on the end that causes some thought. I think that locomotive may well be a 4 or maybe a 5. I don't know, but it's possible, yes.
I think for these types of questions and whatever new rolling stock is introduced, the idea is by having this clear criteria, it can either be done at the design stage or the route compatibility stage, where you can clearly see if a particular configuration meets that criteria, then it is a tick. And even if it might not reach these network wide criteria, at least there's something to go on in terms of trying to justify on a route specific basis how that might be compatible, say. So that's this sort of question is very much what these criteria are aimed at.
I may get my knuckles right for saying this, but I will. So winding right the way back to 2996, why did we as an industry decide that we needed to write down some criteria? The reason was because a new piece of rolling stock came on board, and it was just like the one before, but slightly different. And it was assumed that that would meet the criteria. But I think infrastructure engineers like ourselves, those responsible for looking after the maintenance, are saying, yeah, but everything's an increment on an increment on an increment. When do we stop? When do we draw a line? And the problem was the line wasn't defined. Therefore, you know, the start of this research was really about, we need to do exactly what Paul said. We need to write down something and start from there. You know, deviations, derogations are possible. Challenges to the rules are possible, but if we don't have anything written down to start off with, saying that a class 150 and all the way through to whatever a sprinter now is, they're clearly different things. So in the original sprinter is 11 and a bit ton axle load. Sprinters are now classified with 13.5 ton, and even allowed a little bit more. So things with age have got a little bit heavier.
Okay, great, thank you. So I think it's sort of 6:10, so we'll probably wrap this up. And if there are any other questions, just might stay on for a few minutes at the end in case there's one or two.
Yeah, happy. Yeah, happy to stay on for a while.
So I think it falls to me just to thank you for your time this evening in preparing the presentation and delivering it to us. You gave us a comprehensive review of the process that you've gone through to sort of essentially to demystify the differential speeds. And obviously a lot of reverse engineering work has gone into delivering this. Interesting to learn how we might start to exploit differential speeds in the future as well to unlock some areas of network capacity. So I'd just like to thank you for that and ask our members if you could unmute your microphones, and a round of applause. Josh, please.
Thank you very much. Thank you. Thank you very much.
So I shall stop the recording, and I hope to see people at the next section meeting. Thank you.
Anybody wants to stay on? I'm happy to chat for a little while.